Good afternoon, good evening, wherever you are in the world. Welcome to part 2 of the Weldathon. The absolute marathon continues. This part we begin the actual welding process and the strengthening process, the post-weld heat treating, the machining, and then the final assembly. Be sure to check out part 1 of this video. You get the background of what this machine is and what happened to it and the preparation leading up to this welding. If you enjoy this video and this type of work, be sure to check out my playlists for engineering and welding. There's a stack more heavy repairs in there. If you like what you see, I would be delighted if you'd subscribe to my channel. Your support means a lot and keeps me bringing these videos to you. So yeah, this is part 2. Leading up to this point is all the stripping of the machine, the weld preparation, gouging of the cracks, formulation of a game plan, and we're just at the point in this video where we're actually about to mate the 2 5-ton halves and actually start the welding. So that's just a little preview telling you where we are up to this point. If you want to see all the prior work, as I said, check out part 1. Thanks guys. So with this initial test fit, a few datum points to check. This jaw is a bit more of a prick compared to the other one because the other one, the wear part just sits on a flat surface. This has recesses that the replaceable jaw liner sits on, and those recesses here and up there, obviously that distance is going to be affected by the crack, the break, so I need to ensure that this distance and that distance up there stays the same when repaired. So I'm going to measure between those and then go out and measure the jaw liner to see if they're anywhere near the same, if I need to shim it. So 1370 from there to there. So we'll go and check the jaw liner outside. .7 overall length. So those recesses have massive clearance, so they're not of concern. We'll just check the overall length. These bolt hole centers will need to be checked. 7 foot overall length. So we're getting right down to millimeters now. I weld this scotch on because this top piece needs to move to the right approximately 2 millimeters at the most. So we'll weld that on, drive a wedge in and hopefully move it over. Now I'm going to check the main face which the wear part sits on. This is critical and worth spending an hour or two to ensure that it's correct right down to the millimeter. Absolutely over the moon with that. That's perfection. Absolutely over the moon. So put the scotch and wedge on and wedge it into position. Put the wedge in here to put it over so it's true side to side. We'll measure it on these faces so that there's no twist. And then last of all, I have put in some counter bow. This is compensate for weld shrinkage. So just to exaggerate it, the weld will pull that forwards. So instead of preparing that straight, we actually prepare it with some counter bow, and then the theory is that the weld should pull it as close to straight as possible. And that isn't a precise calculation, it's an experience-based estimation, and I hit it bang on the last time, so hopefully this time should be something similar. So we've got a few nasty gaps to fill because compromised material had to be removed. So next stage is put some very solid tacks, tack this together into one piece, and then we'll begin to position it for some heavy welding, main welding. put some large, very strong tacks on this, because the tacks have to withstand the forces of lifting the entire structure as one unit. So these will be subjected to a lot of weight. Each half's 5 ton, and they'll be lifted and turned and positioned at different angles. So I need these tacks to be very strong. So it's pretty nerve-wracking lifting this and positioning it, because I have to take into consideration that the welds may not be strong enough. Is the material the right material? Could the welds be brittle? Will it break? And every time it's picked up and changed position, you're just waiting for that bang and it to fall into 2 pieces again, and all of the lining up work lost. So whenever you take the tension on the crane, it's like, oh yeah, is this going to stay together? And the more it's moved and the more it stays together, the more I start to relax. So each time I think I've settled on a plan for this beast, I come up with another idea. So I was almost ready to pull the trigger and start preheating and welding. That's the idea of welding along each rib on the flat. Spread the weld out over it. All 1, 2, 3, 4, 5 of them. Then send it off the table, turn it around, putting it back up. I think I'm going to stand it vertical, i.e. that way, and that means I can alternate. For looking at it this way, I can weld here, weld here, weld here, weld here, turn about in order to try and keep the weld stresses even on both sides. It means I can also weld the back at the same time. So I think that's what I'm going to do. The only thing that's concerning me is the sheer height this thing's going to be sticking up in the sky, so I'm going to have to secure it very well to this table to prop it up with a few safety props, because it's going to be a lot of weight standing up in the air. So yeah, it's home time today. We'll have a look at that tomorrow, and if there's enough time left in the day to get some preheat into it and do a bit of welding. I'm getting sort of antsy wanting to get some weld into this now. Stressing over filler material. After lots of research on the web, I'd settled on 312 stainless 29.9. It's a dissimilar metal wire, and it's considered to be ideal for items that are difficult to weld, i.e. in this case where large scale preheating won't be feasible for me. 312 is quite ductile and copes with welding stresses, i.e. shrinkage, base material, maybe differences in temperature. It is supposed to cope with that quite well, but upon actually running a weld of it, I really am not happy with it. It's very waxy, doesn't wet into the base material. It's just not nice to weld. I'm not happy with the fusion, not happy with the penetration. I'm using it with the recommended gas, stain shield heavy, and yeah, it's just my gut feeling, what I'm seeing with my eyes, the way it wets into the base material. I'll try and get you an arc shot. It's not nice. It glazes on the top, but just doesn't wet in, penetrate, fuse in. It's not nice. It bridges, it wants to bridge gaps. It just wants to create lots of inclusions, and I'm not satisfied with it at all. In comparison, just plain mild steel welds like regular metal. I know it's not as ductile in this scenario, and it may suffer from excess stress, but we're going to look at managing that with preheats and things, and then of course normalization afterwards. So I might do some mechanical tests of my own just to test the weld, and on a few temporary joints just to see how it reacts. So yeah, stressing big time, lots of homework to do tonight. Sit up all night on the internet, flipping researching filler wire, but at the moment not happy. So I'll let you know how I get on looking that up. So I'm not going to go with this on its side. I want to reposition it so that it's standing vertical. As I said, this is multiple steps. You have to pick it up first, lay it on the ground so that it's safely down off the table, the work table. Then when it's on the ground, change the lifting points and stand it up on its end. There's an awful lot of time involved in moving something as heavy as this. You have to change the lifting points multiple times, and every time the changing points are changed, you have to adjust the length of the chains. That involves lowering the big hook down, which is all very time consuming. It's crazy the amount of plain manual handling is involved in a job of this size. So watch the chains very closely in this lifting sequence. I have tucked them under the corners because I don't want the corners to foul the chain whenever it is standing completely upright. I'm relying on the angle of the chain to keep it tucked under those corners, but bang, it slips off. That was a massive shock loading to my tack welds and scared the life out of me, but happy days, it didn't break. At this point it's hard to convey how happy I am that my welds didn't break with that impromptu weld test. The chains I'm using to lift are rated far in excess of the weight that I'm lifting, so there's no issue to them. The tack welds have survived that shock loading. This is a good indicator that it is a good metal match to the base material, the welding wire. So finally we'll get some preheat into this monster. Now I've got the propane gas heating torch and a 2 kilowatt heater to maintain temperature whenever I'm not welding or on lunch break. This will take absolutely hours. So preheating is critical. It's critical that there is not too much localized intense heat in one area. There has to be a gradual gradient across all of the areas to be welding as much as possible. I'm doing this with the propane torch and the electric heaters. I try to get the whole entire thing up to as close to 150, 180, 200 degrees as possible. It's not easy, it takes a lot of time, a lot of gas and a lot of electricity to do this. I'm very, very fortunate in this case that our workshop was actually running 24 hours a day with a large job that was taking place next door. This meant that I could leave the electric heaters on overnight to maintain the temperature of this job from start to finish. This was a massive bonus and ensured that it stayed warm right throughout the welding process. fired an absolute stack of oxygen and some propane for preheating, as the preheat was such an important part. The reason for preheating is to negate unwanted stresses during the welding and to keep the hydrogen low in the actual weld itself. This is important even though we're performing normalization after the welding. After the preheat, then we do a little check with the digital thermometer. If it's not warm enough, we'll top it up. If it's too hot, we'll let it cool down a bit. There's a window that's ideal for welding, and the rule of thumb is at least 150 degrees centigrade. So once it's up to temperature, then clean the torch, the welding torch. I'd like to do a video on this torch on its own. If I didn't have this torch, this job would have been an absolute nightmare. It has a special long neck on it, and it made this job an absolute dream. Kept my hands out of the hot pockets, and yeah, highly recommend it if you've got a job like this. We just top off the shroud with some ceramic spray and we're good to go. So this job's a bit of a stress fest, both mentally and mechanically. So we'll just have a little look at some of the stresses taking place. Currently welding this rib here. This pocket was welded yesterday. I'm putting heat into this rib. This entire wall is now growing. When it gets hot, metal expands. Problem is, this is growing faster than this is growing. So if this is 150 degrees, this is 100 degrees. This piece is now bigger than this piece. So it means this joint is now being subjected to this piece of plates pushing the top and the bottom away from each other, which is putting this rib under a tension stretch load. It's being pulled that way and being pulled that way because this is pushing that way and pushing that way as it grows. So the risk is that it could separate along the weld or the edge of the weld because of the different temperatures and the different forces, different stresses being exerted. So very, very stressful, particularly so far into the job. But yeah, just gotta keep going. The trick is to try and have it as even a temperature as possible. The way to do that is to input heat slowly and gradually. These heaters are helping to keep a gradual heat on it, to keep it warm overnight. So you have about 4 kilowatts of heat going into probably 10 tons of metal, and overnight they will keep it quite a good temperature. It's up to about 50 degrees. And holds it at 50 degrees, which gives me a really good base to start to put a preheat into. So even heat is the key, and an even spreading of the weld and weld forces. So if I'm welding this, what I want to do is light the blowtorch and try and expand this to roughly coordinate with the heat and I'm expanding this with, so these grow at a similar rate. That has to be across the board. We want this to grow, that to grow, that to grow, that to grow, all at roughly the same rate. So yeah, juggling match, stress match, and if we can get at the end of the job without cracks, we're over the line. We'll get the post welding heat treatment, bring it up to very high temperature. It'll be glowing red, and that will relieve all of the stress within the weld. I'll talk about that later on in the video during that process and try and explain a little bit how that takes place. So anyway, hopefully get this pocket finished off today. I'm just going to end it. So I never thought I'd see the day. That is all of the internal pockets on the main brake is now rejoined. We've built up all of the huge gaps and it is basically done. Just a few little extra cracks above the main joint that were highlighted. Whenever it goes through a few heat cycles, these become more apparent. This was one of them. And also the welding process can create a magnetic field across the crack, and this attracts particles and filings, also highlighting the crack, just like a welding MPI, magnetic particle test. So that is all of the extra little cracks repaired that were found either side of the main brake point. Welded them and dressed them up. Now we're approaching the stage where I'm beginning to think how I'm going to add strength to this repair, where I can add extra steel and plate to strengthen this. So we just finish off some of these small crack repairs, tidy them up. I'll be looking at tidying up the pockets. Those ends of the welds will be addressed. They'll be back gouged and filled up. So next we're going to start on the very outside welds on each side of the jaw. You can see into the bottom of the root there is absolutely lovely in that nice straight run. However, the far side is a much bigger mess. We have multiple cracks in various different places and messy junctions. All of the root welds that you can see in there will be back gouged into perfectly clean weld, eliminating all flaws and any little issues with that root weld on the inside. I usually consider the root weld a write-off anyway, with the intention of gouging it out completely. the holes at equilibrium distances from all edges. The holes are to tie the belly of the plate, to stop the belly of the plate from breathing when subjected to stress loads. The long pointed edges are to dissipate stress out into a finite point, reducing as it reaches that point, allowing the edge of the strengthening plate to move with the body if that takes place. If you make a large termination of the strengthening plate, it can't move, therefore it's more likely to crack. Just making a quick trip to the quarry, to the body of the large crusher, in order to take some width measurements of the inside of the body, just to make sure that I don't make the jaw too wide. If it's too wide, obviously it won't fit inside the main body, so I'll just get a quick measurement of the inside of the body. A lot of good stuff in it. That is a big girl. That is a beast. So it's 13.25 from the rib to the rib. So we'll grind all the rust and burning snotter off the edges, prep it all up, clean it all up, grind the paint off the jaw, preheat it, start welding. That's one side welded up. I'm happy with that for an old boy. An old boy that's past his base and losing his vision. That'll do me. So yeah, that's one plate on. 6 runs, 5 plugs, preheat, 2 hours. Definitely smashed that one hard. So yeah, let's get her turned over and have a look at the next side. Going to turn it over now and start to see about filling this Grand Canyon on the back. So I get to wrestle with some of my favourite things, such as these lovely greasy chains that some very considerate person left at their backside. Cheers for that, buddy, whoever you are. So yeah, I'll start wrestling these greasy, bloody, twisted chains and flip it over on its back. Oh, I don't know. It wouldn't be so hard if it wasn't for others. Alright, let's get into it. So that's the little runoff plates. Just means you can bring the top up nice and square and then cut it off afterwards, and you're back out of all the start and stop joints. Get a wire wheel in there and clean off gouging, carbon, dust. Colossal bit of welding ahead of me. See the pliers just for scale. Let's just get a little depth measurement of that. Yeah, we're just over 70 mil deep. Colossal. 70 mil deep and good 40 mil wide. So that's nearly 2 3/4 or 1 3/4 wide and 2 3/4 deep. So yeah, get a stack of heat into this. I'm reasonably nervous about this weld because I have to put a lot of preheat in, which is a lot of growth, but because it's such a big gap filled with a lot of weld material, there'll be a lot of shrinkage on this too. So yeah, definitely going to be a bit nervous, but we'll heat her up and get in there, keep her nice and warm, and let her cool down slowly. Should be all good. Alright, I'm going to get another roll. Approximately 2 rolls of wire into that so far, and we're not done yet. Man, oh man, am I glad to see that filled. Nothing of sores on the flipping bollies. Leaning on your elbow, crawling around on the floor on top of this flipping lump of steel. Elbow is absolutely junk. But on the positive side, that's it done. That's the back, the outsides, the ribs, 2 side plates done. So I'll turn it over, put the plates on the inside, and that will be it, I reckon. Just about 1 more week's work on the plates on the insides, and she is out of my hair. Just have to grind up the runoff plate weld stub, polish it in nicely, and that's it. Looks like a bloody ploughed field on camera. It ain't that bad, it'll do, it'll do. It's not Instagram worthy, but I'm not bothered. YouTube's where it's at. You guys, that's where all the love's at. Give me a thumbs up for a back-breaking job. Give me a super thanks if you want. Buy me a bottle of water. much appreciated. I'll keep this content coming to you. So yeah, we'll go for some lunch, we'll come back and turn it over. Sorry to do this, guys, but here we are. We're rolling up on over an hour's footage. I hate to split the video into parts, but nobody's going to sit through 3 hours of footage. So the good part is it means there is the final finale coming up soon. It will be an incredible bit of footage. There's some heavy duty machining. We make bushes out of large stock pipe and freeze them in with liquid nitrogen, and you'll see our big lathe checking the shaft as well. I also have some brittle strengthening plates to go on the inside of the jaw, so some fantastic footage coming up for the machinists and engineers, and lots more welding. So I hope you guys enjoyed the video. If you did, just the usual, I appreciate every thumbs up, like and subscription. Only 10% of my viewers are subscribers, so if you're dropping in, I'd love you to stay. Click that subscribe button. Check out my playlists. I put up a great variety of stuff from engineering, off-roading, tuning diesel engines, you name it, something for everybody. So be sure to check out my playlist. You never know what you might find in there. So, as always, guys, appreciate the support, and I'll catch you on the next one. Thanks.